August 1943, a remote airfield somewhere in occupied France, a place of mud, ration lines, and the permanent hum of anxious engines. The kind of field where pilots ate quickly, slept badly, and measured their days by the readiness of their machines. Oberleutnant Verner Schulz, the chief technical officer at Jagdgeschwader 26, had been called out of briefings and late-night paperwork, with the clipped urgency of people who understood value when it landed in their lap. The message that reached him would, under normal circumstances, make a Luftwaffe engineer jump with something close to exhilaration. An American P-47 Thunderbolt had crash-landed not far from the village. The pilot was in custody. The aircraft, largely intact. For a mechanic's mind, this was the equivalent of a treasure chest. Intelligence officers dreamed of radios, cryptic plans, or new guidance systems. Engineers dreamed of metal, tolerances, and the secrets hidden in rivet patterns. But when Schulz finally walked out across the cracked tarmac and saw the Thunderbolt sitting there, his first and most human reaction was the same one German pilots had when they first met the type in the skies. It looked ridiculous, bulbous, almost comical, like someone had strapped wings to a flying barrel. The Luftwaffe men had a nickname for it, the Fliegende Zigarre, the flying milk bottle. And if you judged on silhouette alone, it was hard to argue. Schulz, however, wasn't a fighter jock trading barroom insults about enemy aesthetics. He was a numbers man, a trained engineer who'd cut his teeth at Messerschmitt before the war turned theory into survival. His job was clinical and mercilessly practical. Determine what the enemy's machines could do, where they were vulnerable, and how to exploit any weakness. He didn't care whether a plane was handsome. He cared about what lay under the skin, and what he was about to find would leave him shaken in ways no dogfight ever could. He began where any precise mind would, at the heart. The cowling came off with a practiced motion, mechanics working in a rhythm honed by years of winter nights and hurried repairs. Underneath sat the Pratt & Whitney R2800 Double Wasp, a radial engine of theatrical proportions. 18 cylinders arranged in 2 perfect rows of 9, each one glinting with the kind of finish Schulz's crew had only seen in brochures and captured components. It was a radial monster that explained the Thunderbolt's shape. The broad fuselage and stubby nose existed because something the size of a small building had to live there. But size alone didn't account for the silence that fell over the German crew. The craftsmanship radiated from every surface, machined edges, perfectly concentric fittings, bearings that looked like they'd been hand-polished. Schulz touched a cylinder head and felt the cool assurance of precision. He began to run numbers mentally. Displacement, compression ratios, volumetric efficiency, and the estimates stacked up to a single, terrifying conclusion. This engine must be producing at least 2,000 horsepower. Perhaps more once you factored in the turbo-supercharger mounted deep inside the airframe. For context, the WW2 that powered the FW190, Germany's current frontline workhorse, was a remarkable achievement. But it topped out around 1,700 horsepower in its most extreme forms. And even then, only after pushing German manufacturing to the edge of what it could sustain. Seeing the R2800 laid bare, Schulz felt a professional admiration that sitting next to professional unease. The Americans were casually mass-producing motors with 20 to 30% more power. They did so with a finish and consistency that suggested not desperation, but industrial abundance. His search for shortcuts or corner cutting practices, the kind of compromises that wartime scarcity forces on manufacturers revealed nothing. No inferior alloys, no improvised bearings, no jury-rigged bracing. This engine was built with premium aluminum, high-grade steels, and component tolerances that sang of a supply chain able to feed precision factories rather than the other way around. One of Schulz's mechanics, a man soot-stained and skeptical from years of field repairs, pointed at the cylinders with a rare note of wonder. "Herr Oberleutnant, look, each cylinder unbolts separately. Swap one out and you're back in the air." The implication was obvious and profound: maintenance philosophy baked into design. Quick modular repairs that reduced downtime and kept more aircraft flying. Then Schulz's gaze shifted rearward, and he saw the real technical marvel, the turbo-supercharger plumbing. A complex network of ducts ran from the engine back through the fuselage to a turbine assembly mounted near the tail, a graceful yet brutal engineering solution to the problem of thin air. The system harvested exhaust energy to spin a compressor at tens of thousands of revolutions per minute, forcing pressurized air back into the engine at altitudes where breathing itself grows thin. The engineering complexity, temperature-resistant ducting, high-speed turbines, precision bearings, was staggering. These were not tinkered prototypes. This was production hardware, installed in numbers on frontline fighters. German engineers had experimented with turbocharging and supercharging, of course. But the lessons of supply shortages, brittle alloys, and the need for simplicity in the field had left German solutions more fragile, more temperamental, under the stresses of combat and maintenance. To see such a system in regular American service, reliable, maintainable, and widespread, pushed a cold, professional dread through Schulz. He began to calculate the tactical implications. At 25,000 feet, the P-47 retained full power where German machines began to struggle. In practice, that meant dominance of high-altitude intercepts, the very altitude where Luftwaffe pilots had to fight to reach Allied bombers. When his assistant asked the quiet, inevitable question, "Can we build something like this?" Schulz's answer was bluntly practical. Not with our current factories. He could see in the mental map of production lines and metal shortages the impossibility. The turbo system required machining precision, special steels, and a degree of industrial redundancy Germany no longer had. The Americans had not merely produced a better fighter. They had created a machine that embodied an industrial edge Germany could not hope to match with its stretched manpower and materials. Moving from engine to airframe, Schulz's examinations continued with clinical detachment. This particular P-47 bore the scars of a fight: cannon and machine gun hits, ragged tears in the wing skin, and bullet-pocked surfaces where explosive fragments had struck. Yet somehow it had flown home. The damage patterns told a story repeated in Luftwaffe damage reports. Pilots would pour shells into Thunderbolts and watch in stunned disbelief as their targets stayed airborne. The answer lay in the P-47's philosophy of construction: heavy-gauge aluminum skin, reinforced internal spar work, and redundant control linkages combined to create a toughness German lightness had eschewed. Schulz ran his fingers along an internal spar and noted the robust cross-bracing, the generous fillets, where stress concentrations were smoothed rather than left raw. Cockpit armor I in the P-47 was substantial, with thick steel plates forming a protective cocoon. The windscreen used armored glass of a thickness few German cockpits matched. And crucially, the radial engine architecture itself was inherently more survivable. Unlike liquid-cooled inline engines, vulnerable to a single punctured coolant line, a radial could sustain damage and continue functioning, simply because it didn't rely on a pressurized coolant system to keep running. Shoot out a few cylinders and you limp home. Shoot a coolant pipe on an inline and you watch your engine bleed to death. An engineer in Schulz's group voiced what many were thinking. They've overbuilt it. Weight where weight shouldn't be. On the surface, that criticism fit the German aesthetic: light, nimble, efficient. Schulz allowed a slow nod. True, but they can afford it, he replied. The Americans traded margins and weight for survivability because their engine power could carry the penalty. German design, starved of raw horsepower and raw materials, had to be optimized down to the last gram. It was a fundamental split in philosophy, and in the cold calculus of war, it was proving decisive. Lastly, the weapon systems. 8 Browning 50 caliber machine guns, 4 in each wing. A fearsome sight even on paper. Schulz ran the ammunition math in his head, roughly 400 rounds per gun, a total ammunition load on the order of 3,200 rounds. The combined rate of fire for all 8 guns pushed well over 100 rounds per second. A 1-second burst became 100 heavy slugs ripping through air and metal. A standard 2-second burst was essentially an ammunition torrent. Compare that to the BF-109 or FW-190, a mix of lighter machine guns and heavier but sparser cannon. German fighters carried comparatively limited ammunition. Once those hoops were emptied, you were done for. A P-47 pilot could sustain a devastating volume of fire for prolonged windows of engagement. Schulz closed his notebook that night with a mixture of professional respect and a gnawing realization. He had seen captured aircraft before. He had catalogued rivet patterns and hydraulic schematics, but the Thunderbolt was not a single breakthrough. It was an expression of an entire industrial ecosystem: abundant power, maintenance-minded design, survivability at the core, and concentrated firepower. It was a machine built to be messy in the best possible way, heavy where it mattered, powerful where necessary, and forgiving when the sky turned into a bottle of shrapnel, walking back across the field as dusk thickened. Schulz watched the silhouette of the P-47 against a bruised sky and thought about people rather than parts: the industrial workers in distant factories, the engineers who had argued for maintenance-friendly designs, the pilots who trusted their machines to soak up punishment and return them home. The plane looked ridiculous in daylight, but in the math of performance and production, in the ledger of lives saved and sorties kept flying, it was terrifyingly effective. And that, more than anything, was what haunted him. Not the shape, nor the parts, but the quiet, unassailable fact that Germany was fighting not just machines in the sky, but an opponent whose manufacturing capacity had, in many critical ways, already won the duel. But quantity alone didn't tell the full story. Schulz leaned over the scattered ammunition belts and individual 50-caliber rounds, turning each over in his hands, feeling their weight and studying their construction. These were not merely bullets. They were meticulously engineered, high-velocity projectiles designed to punch through metal like it was tissue paper. The sheer mass of the slug, combined with its speed, meant that armor or structural reinforcement offered only temporary protection. He recalled reading first-hand pilot accounts describing P-47 fire as a literal wall of lead, a concentrated storm that would shred anything unlucky enough to fly through it. Now, seeing the rounds up close, he understood precisely why those accounts weren't exaggerations. With 8 guns converging on a single focal point, any aircraft caught in the target cone would be ripped apart in seconds. The P-47 didn't need precision in the sense German doctrine demanded. It didn't need a carefully aimed burst. Bring the enemy roughly in front, squeeze the triggers, and the destruction was inevitable. It was terrifying in its simplicity. Schulz scribbled a note in the margins of his report: avoid head-on engagements with P-47s whenever possible. Probability of survival under direct return fire, essentially 0. As he sat in the dim light of his office, compiling observations into formal reports, an overarching pattern began to emerge. A pattern that transcended the genius of any individual system and spoke instead to an industrial sophistication that was profoundly alarming. Every element of the P-47, engine, airframe, turbo-supercharger, armament, traced back to a logistical and manufacturing ecosystem almost unimaginable from the perspective of German industry. The R2800 engine alone demanded the sort of precision machining, high-grade alloys, and skilled labor hours Germany struggled to maintain. The turbo-supercharger required advanced metallurgy and engineering know-how, far beyond what most Luftwaffe plants could handle consistently. The aircraft's airframe called for massive quantities of aluminum, a resource increasingly scarce in Germany. Even the ammunition, 8 guns worth of 50-caliber rounds, tens of thousands per month for an entire squadron, demanded a functioning munitions industry producing millions of units with precision tolerances. Any single system like this, operating independently, would strain German industry. Integrated together in one machine, it was almost inconceivable. And yet, America was mass-producing them in numbers that would make Schulz's head spin. Determined to quantify the reality, Schulz requested production data through intelligence channels. When the numbers arrived, they were almost physically painful to read. Republic Aviation alone was building P-47s at a pace that, to someone grounded in German manufacturing, seemed impossible. By late 1943, over 500 aircraft were rolling off their assembly lines every month. Plans aimed to increase that to 600, 700, and eventually 800 monthly by 1944. Meanwhile, German factories were struggling to produce 300 to 400 single-engine fighters per month across all designs combined, often hampered by Allied bombing raids that tore through production facilities, disrupted supply chains, and demoralized workers. The gap in both volume and reliability was stark, and its strategic implications chilling. The R2800 engine's ubiquity amplified the disparity. Not only did it power the P-47, but it also saw service in multiple other American aircraft types. Total wartime production would surpass 125,000 units, more than Germany could produce in total aircraft engines for all models throughout the entire war. To put this in perspective, Germany's total aircraft engine production for the war, across all models, reached roughly 250,000 units, most of which were significantly underpowered compared to the American radial. The United States was producing more of a single advanced 2,000 horsepower engine than Germany could manage in totality. The sheer scale was mind-boggling. Schulz rechecked his math, thinking he must have misread the figures. He didn't. In 1943 alone, projected American aircraft production exceeded 85,000 units, while Germany expected perhaps 25,000, a ratio greater than 3 to 1. And yet, the story was even worse than the raw numbers suggested, because American planes were, on average, heavier, more complex, and far more resilient. A single B-17 bomber required more labor, materials, and assembly hours than 3 Bf-109s. The Americans weren't just outproducing Germany. They were outproducing in scope, scale, and sophistication, simultaneously fighting a global war, supplying the Soviets through Lend-Lease, equipping British forces, and maintaining their own home front defenses. When it came time to draft his official report, Schulz realized the danger of his conclusions. What he was writing wasn't mere technical analysis. It was a report that challenged ideology with cold, immutable numbers. He meticulously laid out the P-47's advantages: engine power, high-altitude performance, armor, structural resilience, and overwhelming firepower. He quantified the limitations of German aircraft and noted the impossibility of matching American industrial output with existing resources. His conclusion, written plainly and mathematically, would surely be labeled defeatist. The P-47 Thunderbolt represents industrial and technological sophistication exceeding Germany's current capabilities. Its widespread deployment indicates American production capacity far surpasses previous intelligence estimates. Recommendation: tactical adjustments to minimize high-altitude engagement with P-47s. Strategic assessment: continued attrition against numerically and technically superior enemy aircraft will produce unsustainable losses. When his commanding officer read the report, his expression was a mixture of respect, concern, and something Schulz recognized as fear. "You understand Berlin will not want to hear this?" he asked, voice low and steady. "They do not tolerate intelligence, suggesting the Americans have outmatched us. Should I change the findings?" Schulz asked, though he already knew the answer. "No," the officer said, shaking his head slowly. "It is accurate, but brace yourself. Leadership does not handle uncomfortable truths well." The report went up the chain, filed with bureaucratic diligence, and then silence. Through back channels, Schulz later learned it had been dismissed as overly pessimistic. One staff officer allegedly remarked, "This engineer has been demoralized by enemy propaganda. The P-47 is crude, inferior American engineering, nothing to fear." Schulz wasn't shocked. He had seen this pattern before. Intelligence that contradicted the Third Reich's ideological narrative was routinely ignored or actively suppressed, regardless of its accuracy. Yet personally, examining the P-47 had changed him. Not just his perspective on a single aircraft, but on the war itself. In the months that followed, his predictions proved tragically accurate. P-47s appeared in increasing numbers across European skies, German fighter losses climbed, and seasoned pilots were shot down faster than replacements could arrive. The tactical adjustments he had recommended, avoiding high-altitude confrontations, employing hit-and-run attacks, focusing on surprise engagements, were eventually implemented. But the implementation came too late. The Americans had seized air superiority through a combination of sheer numbers and technological advantage. Other captured American aircraft reinforced the same conclusions. Each machine bore the marks of superior design philosophy, material quality, and industrial capability. A captured C-47 transport revealed a logistical backbone Germany could not match. Thousands would be produced, while Germany had only a few hundred often obsolete transports. The P-51 Mustang combined the P-47's ruggedness with extended range and higher performance. Powered by the Packard-built Rolls-Royce Merlin engine, manufactured under license in the U.S., every captured aircraft told the same story. The enemy had industrial, logistical, and technological superiority, and Germany was increasingly outmatched. What haunted Schulz most was the tragic inevitability of it all. The intelligence was available, observable, measurable. German agents were producing detailed reports. Captured equipment demonstrated superior quality, yet leadership refused to confront the reality. Or rather, they confronted it and chose to deny it. They believed willpower, audacity, and tactics could overcome overwhelming material disadvantages. Schulz, trained in the certainties of engineering, knew otherwise. Numbers do not lie. Material reality does not bend to ideology. Germany was being buried under an avalanche of American steel, aluminum, and firepower. After the war, when production figures were declassified, Schulz's estimates proved conservative. American output had exceeded even his most pessimistic projections. Between 1940 and 1945, the United States produced over 300,000 aircraft, Germany approximately 94,000. More than 15,600 P-47 Thunderbolts were built alone, surpassing all German Bf-109s and FW-190s combined. The R-2800 engine? Over 125,000 units emerged, produced not just by Pratt & Whitney, but also by converted automotive factories. Ford, Chevrolet, and other manufacturers repurposed for war production. Shipyards building freighters turned to aircraft carriers. Every facet of American industrial mobilization was unprecedented, combining mass production, engineering precision, and unwavering quality. German aircraft, by contrast, increasingly reflected the strain, lower-grade materials, simplified construction, and quality control problems as skilled laborers were drafted or replaced by forced labor. Schulz survived the war and was later interrogated by American technical intelligence officers, who were particularly intrigued by his 1943 P-47 report. One officer asked, "Did you really conclude from examining a single aircraft that Germany would lose the war?" Schulz paused thoughtfully. "I concluded that Germany could not win an industrial war against America. The P-47 was proof. Every component, every system demanded resources and manufacturing capabilities beyond our total capacity." The officer pressed further. "But you were just one engineer. Surely others saw this." "Many did," Schulz replied quietly. "But in the Third Reich, speaking inconvenient truths was dangerous. Better to stay silent than be branded defeatist." The American officer nodded. "We found your report in captured files. Marked filed, no action required. Surprised? Schulz laughed bitterly. No, I expected it. Nazi leadership did not want intelligence. They wanted validation. When reality contradicted ideology, reality was simply dismissed. The P-47 had revealed, more than itself, it had revealed the unvarnished truth about a war Germany could no longer hope to win. The story of Verner Schulz and that captured P-47 Thunderbolt is far more than a footnote in the history of World War II. It is a distilled example of Germany's larger strategic failure, a lens through which the war's ultimate outcome can be understood. Schulz, a highly trained engineer with years of experience in the technical heart of the Luftwaffe, had been handed a rare opportunity to examine, in painstaking detail, an enemy aircraft in near-perfect condition. What he discovered wasn't just impressive engineering, it was a revelation about the industrial, logistical, and strategic imbalance between Germany and the United States, an imbalance that Germany's leadership stubbornly refused to acknowledge. As he meticulously documented the P-47's engine, airframe, turbo-supercharger, armament, and structural resilience, Schulz realized the numbers told a story far harsher than any personal opinion could convey. Every calculation, every comparison, every note reinforced the same conclusion. Germany was being systematically outproduced, out-resourced and out-engineered in ways that could not be corrected by heroism, ingenuity, or sheer willpower alone. Yet when he compiled his report and submitted it to the Luftwaffe High Command in Berlin, it was dismissed as pessimistic or defeatist. This wasn't an isolated instance of bureaucratic myopia. Schulz's experience reflected a recurring pattern within the Third Reich. Competent, informed individuals recognized the strategic realities, yet found themselves trapped in a political and military culture where ideology consistently outranked truth. Consider the parallel cases. Admiral Wilhelm Canaris, head of the Abwehr, who warned that American industrial capacity would decisively shape the war's outcome. Albert Speer, Minister of Armaments, who openly acknowledged Germany could not sustain a production war against the Allies. Adolf Galland, the Luftwaffe ace, who understood the P-47's tactical superiority and the vulnerabilities it exposed in German aircraft. And Sepp Dietrich, who predicted the failure of the Ardennes offensive due to critical fuel shortages. In each of these cases, individuals who combined practical experience with analytical insight were ignored. Their reports shelved, their warnings dismissed as incompatible with the grandiose myths of German invincibility. Competence, insight, and reality repeatedly collided with ideology, and reality lost. The Nazi worldview was rooted in the conviction that German racial and cultural superiority could overcome material deficiencies. The regime glorified willpower, cunning, and bravery as forces capable of transcending logistical and industrial limitations. But the P-47 and Schulz's meticulous observations proved otherwise. Willpower did not manufacture aluminum. It did not refine aviation-grade steel. It did not produce tens of thousands of high-performance engines and aircraft each year. America's factories did all of that, and in quantities that were staggering, reliable, and sustained over years. Germany could fight skillfully, deploy elite pilots, and achieve tactical brilliance, but it could not fight the industrial reality. Schulz understood this immediately upon examining the captured Thunderbolt. The P-47 was more than an aircraft. It was a testament to an entire nation's capacity to mobilize, organize, and execute industrial power at a scale Germany could not match. Its engine alone, the R-2800, symbolized what Germany could never achieve without an impossible expansion of resources and labor. Its airframe, turbo-supercharger, and armament systems further underscored the reality that American design philosophy assumed the availability of resources that Germany simply lacked. Each component was a microcosm of an industrial ecosystem, interconnected, optimized, and mass-produced. And this wasn't an isolated example. Every American aircraft Schulz would examine afterward confirmed the same harsh truth: superior materials, sophisticated systems, and a production scale that Germany could not hope to approach. Schulz's P-47 report should have served as an alarm bell, a call for a fundamental reassessment of Germany's strategic position. If military and political leadership had internalized its findings, the Reich might have adjusted its planning, focused on defensive attrition, preserved fuel and resources, or delayed offensives until a more realistic assessment of capability could guide strategy. Instead, the report was filed and forgotten. Bureaucrats and ideological adherents were unwilling or incapable of acting upon inconvenient truths. The P-47 went on to become one of the most produced fighters of the entire war. Over 15,600 Thunderbolts were built, each one destroying hundreds of German aircraft, supporting every major Allied invasion and contributing decisively to air superiority over Europe. That superiority, once achieved, was nearly impossible to reverse. By the time the Luftwaffe recognized the scale of the threat, it was already too late, and it all began with one engineer quietly observing, calculating, and documenting. Schulz realized that Germany had already lost a war it barely understood it was fighting. Not a war measured by soldiers or tactical brilliance, but a war fought in factories, steel mills, and assembly lines. It was a war of resources: oil, aluminum, steel, skilled labor, and the ability to convert raw materials into functional, reliable, and deployable machines at massive scale. America possessed all these things in abundance. Germany possessed precious little, and the gap widened with every month of conflict. Every new P-47 that took to the skies, every B-17 bomber rolling off American assembly lines, and every shipment of material to Allied fronts reinforced the truth Schulz had discovered. Victory depended on industrial power, not bravery alone. The tragedy of Schulz's story lies not in ignorance, but in the gap between knowledge and action. He knew the truth, calculated it with precision, and documented it comprehensively. He saw the enemy's capability laid bare and understood its consequences for the Reich, yet his knowledge could not change a system that valued myth over reality, ideology over evidence. The P-47 became a symbol of that industrial and technological superiority, a single aircraft representing thousands of factories, tens of thousands of engineers, and an entire economy converted to total war. It was proof that technical excellence, when paired with industrial scale, could determine the outcome of a global conflict. In the end, the P-47 story, and Schulz's role in observing it, encapsulates the decisive element of World War II, the war Germany lost before the first shots were even fired. In the quiet, humming factories of America, where numbers, machinery, and production capacity ultimately dictated the fate of nations. Schulz's experience, repeated across multiple theaters and fronts, demonstrates the cruel arithmetic of modern war. When ideology blinds leadership to material reality, even the most brilliant and courageous individuals are powerless to avert the inevitable.